Alright, so in this video we're going to continue with where we left off with in lesson 3.5 with still learning about how to find zeros of polynomial functions. And in this video we're going to be looking at some story problems and some other application problems for what we learned in the previous lesson or the previous part of this lesson. But first let's start with just reviewing. So I want you guys to take a minute and I want you to see if you can match these equations with their graphs. And please do not use a graphing calculator. The idea here is that you should be able to do these just by looking at them and knowing what the x-intercepts would be and using multiplicities to determine whether or not the line goes through that x-intercept or if it's a turning point or reflection point at that x-intercept. So I want you to match these three equations with their graphs. So go ahead and pause the video and hit play when you're ready to check to see if you've done them correct. Alright, let's see how you did here. So for that first one, if you notice there, they have an exponent of 1 or multiplicity of 1. So that means it would go, the graph is going to go through those x-intercepts. And the x-intercepts then would be at 1 and negative 2. So the graph that goes through those two, or the one right behind me here, graph letter F. Now the second one, letter B. That one, x minus 3 has a multiplicity of 2. So that x-intercept of 3, it's going to be a turning point or bounce. It's going to bounce off the line at that point where x is 3. The other x-intercept where x is 1 has a multiplicity of 1. So that means since it's odd, it's going to go through that x-intercept. And so that would bring us to the middle graph, graph E. Now obviously, process of elimination, we know that equation C and graph D would match up, but let's see why. So x plus 1 squared, so that's an even multiplicity, so it's going to reflect off that point or bounce off or have a turning point at that one, and that would be where x is negative 1. And x minus 1 cubed, that's an odd multiplicity, so that means it's going to go through that x-intercept where x would be 1. So the graph where it goes through where x is 1 and has a turning point where your x-intercept is negative 1 would sure in fact be graph D. All right. So in this example, we're going to be looking at a story problem. And so here it says Acme Innovations makes and sells lamps. Their profit in hundreds of dollars earned is a function of the number of lamps sold, X in thousands. So let's stop there for a second. So the variables here, X represents the number of lamps that they're going to sell in thousands. Okay, not just number of lamps, it's the number of lamps in thousands. So when X is 5, that represent 5,000 lamps, just to be clear. And your Y values are in thousands, or I'm sorry, in hundreds of dollars. So a Y value of 5 would represent $500. Okay, so from historical data, they know that their company's profit is modeled by the function shown. And so the function that they're talking about is this one, right there. Okay, so what do the zeros of the function tell you about the number of lamps that Acme Innovations should produce? Okay, so we can look at this graph. We could identify these zeros as being where x is negative 2, where x is 3, and where x is 10. Okay, so those are the x-intercepts. Again, you can do that just by looking at the graph. Those 3 points. Now, the graph, the book actually makes this a lot harder than it has to be. So let's think about this logically. So this represents the profit. And so really all we're concerned about is quadrant 1. Because in quadrant 2, that's where x would be negative. And we don't care about a negative sales in lamps. Quadrant 3 doesn't matter. Quadrant 4 doesn't matter. So the only one that matters is quadrant 1, because that's where the profit is going to be, the x values are going to be a positive number, and our profit, our y values are going to be a positive number. So when we look at that graph, we want to look to see where, because again, we're trying to figure out what do the zeros of the function tell you about the number of lamps that Acme Innovation should produce. And so that tells us, so when we look at that graph, that part of the graph is the only part of the graph in quadrant 1 where it's positive. So if they sell between, so now this is where x is 3 and where x is 10, that number of lamps is going to give us a profit of more than $0. Now remember, x being 3 means that that's 3,000 lamps. So the company should sell between 3,000 and 10,000 lamps to make a profit. That's it. That's what the graph tells us. So in other words, here's what we're getting at. If we want to find the x-intercepts, we can use our graphing tool to be able to find those x-intercepts, and then we can look at the shape of the graph, if it's a story problem, to figure out where we're going to make a profit or what values we want to use. And that's all they're telling us here. So we don't have to go through doing factoring. We can make this a lot simpler than what the book does. But let's look at this one. It says Acme Innovations makes and sells lamps. So again, the same situation. This time the profit in hundreds of dollars. Oh, so it's still the profit is in hundreds of dollars, and X is referring to the number of lamps sold in thousands. Due to a decrease in the cost of materials, the profit function for Acme Innovations has changed to be this now. Okay, how many lamps should they make in order to make a profit? So let's work on this one together. So for this one, we're going to need our graphing calculators. So let's get our graphing calculators out. All right, so go ahead and type in the equation that we're going to be graphing our profit function into your graphing calculators. So go ahead, and if you need to, pause the video so then that way you're all caught up. All right, so let's look to see what the graph looks like. All right, now I got to figure some things out here. Okay, so this graph right now looks like a parabola. Okay, because it looks to me kind of like it looks like a U. Is it supposed to be a parabola? Let's go back to our equation. It's negative x cubed. Remember, we can look at the shape of the graph by that first term. And so the fact that it's a negative 1, what does that mean about our end behavior on the right side of the graph? Think about that for a second. Is the end behavior on the right side of the graph supposed to be going up or going down? Hopefully you're thinking that, well, if it's negative, it should be going down on the right. Well, what's our graph doing? It looks like the right side of the graph is going up. So what does that mean? Does that mean that there's something wrong with our graph? Does it mean that we're not seeing all of the graph? Maybe that's the case. I'm guessing that's probably the situation. I'm guessing that this graph probably comes down, comes up, and then it's going to come down again somewhere on the right. Because if you look at, so something else that we could also identify is this is an odd power. Okay, the degree is an odd power. It's 3. So that means that the end behavior also is not going to be going the same direction. They're going to be going opposite directions. So the right side of the graph should be going down while the left side of the graph is going up. And so when I look again at this graph, the left side of the graph is currently going up, but the right side of the graph is also going up. So that means it should be coming down at some point. So we're going to have to change the window settings. So we could do that. So we could go to the window settings, and we could do it this way. Now I've already played around with this a little bit to figure out what our window settings should be. There's oftentimes no like quick, easy way to do it. Sometimes you just have to use trial and error. But here's what I ended up coming up with. So I came up, and we're going to leave our x minimum at negative 10 because the left side looks fine. But the x maximum, let's go a little bit further on the right. Let's go up to 15. And we could just use an x scale of 1 if we want, meaning you're going to count along the x-axis by 1s. If you want to change that to be 3s or 5s, you're welcome to. The y minimum. Let's go ahead and make this a little bit lower. Let's go down to negative 100, just so we can see a better idea of what the graph looks like vertically. And we're going to go up to a y maximum of 500. And obviously we don't want to count by 1s, otherwise it's going to look like the solid black line. So let's count by 50s here. Whoops. 50. There we go. All right, so now let's look at our graph. All right, now that's a much better looking graph. So again, sometimes just trial and error to get a graph like that. So we're trying to find out when would we make a profit. So now if you can't remember what we're counting by, or if we're not even quite sure what those x-intercepts are, here's how you're going to find that. If you go to second and then go to calculate. Okay, so above trace, we're going to calculate what the zeros are. So it gives us this little x, and so we're going to set that anywhere to, because notice down here below here it says left bounce. We're going to set that anywhere to the left of where x-intercept should be and hit enter. Now if you notice, it gives it a dashed line, and it changed now to say right bounce. So we're going to drag that over to where the right of that x-intercept would be and hit enter again. Now notice they give us these dashed line with these arrows, so it's saying that do we want to find the x-intercept between those lines? And yes, we do. So hit enter one more time, and now we can see that our x-intercept there is 1. Okay, so let's go further. Let's try to figure out what that x-intercept would be, or we could just assume that it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's see, could it be 11? I don't know. So what we're going to do is we're going to do the same thing. We're going to go to second and then calculate. Again, find the zeros. Let's just arrow that over. Okay, so that's good there. So we're to the left of my x-intercept, go to the right of our x-intercept, hit enter again, hit enter a third time, and sure enough, yep, x is 11. So our two x-intercepts are 1 and 11. So between, now remember, this represents thousands of lamps. So between 1,000 and 11,000 lamps, now we would have a profit. So let's go back to our presentation. So again, in the context of this problem, the 3 and the 11 represent between, the 1 and the 11 represents between 1,000 and 11,000 lamps. So that's how we'd want to write our answers. All right, let's look at another example. So we're going to skip to example 6, I believe. And so example 6 says solve a polynomial inequality by graphing. So what we're going to do for this problem is we are actually going to do this without a graphing calculator. Okay, now I know it says that we could do it by graphing, but I just want to show you because it's important to recognize some other ways we could do this in case next year when you're taking pre-calculus and you're not allowed to use a graphing calculator in certain situations to be able to do this by hand. And so we have the skills we need to be able to solve this and try to find, because we want to start by finding out where is it less than 0. Okay, so we want to figure out, basically we want to start by finding the x-intercepts. And so let's use factoring to do that. So I notice that these both have an x in them, x cubed and x. So I'm going to factor out an x. So we would have x squared minus 16. Now I notice that x squared minus 16 is a difference of squares. Remember that from earlier in this chapter. So that factors down to be x plus 4, x minus 4. So again, what we're trying to do is we're trying to figure out what are the x-intercepts. And so to find the x-intercepts, we would set each of these factors equal to 0. So the x-intercepts are going to be at 0, -4, and +4. So let's sketch a graph of what that line would look like. And use what we've learned about. So we know the x-intercepts, again, we'd have an x-intercept at 0, 1, 2, 3, 4, 1, 2, 3, 4. So we would have an x-intercept at -4 and at +4. Okay, now let's think about what this graph is going to look like. Okay, the graph is a cubic, so we got a exponent or a degree that's 3, so it's an odd power, so that means they're going to be going in opposite directions. It's positive, so the right side of the graph is going to be going up, and the left side of the graph is going to be going down. So now we're just going to connect those. We have a line that's going to look something like that. So now we're trying to figure out when the value is going to be less than 0. So where is this graph where the value is less than 0? Well, that's going to be down here and right here. So we want to describe the intervals where that happens. So that first interval is from -infinity. Let me give me my pen here. So that first interval is going to be from -infinity to -4. Okay, so that first interval, it's negative when x goes from -infinity to -4. And the graph is also, the function's also going to be negative from when x is 0 to when x is +4. And that would be our answer. All right, I want you guys to try one on your own. Now this one, I'll just give you a hint here as far as if you were to multiply these together. If you wanted to figure out what the degree of the polynomial was, if you distributed the x squared through, or if you set up a box, you don't have to find the whole thing. But if you wanted to figure out what that first term would be, x squared times x squared would be x to the 4th. So here's what this tells us. This tells us the degree of this entire polynomial, because remember, when we find the degree when it's in standard form. And so the degree, if we were to multiply this all together and get it in standard form, the first term would be x to the 4th. So I want you to recognize that this is an even degree, and the a value would be positive. Now it's not completely in factored form. Okay, x squared minus 1, that's a difference of squares. And I'll tell you, x squared minus x minus 6, that can be factored. Okay, remember when using the box method, or you might recognize that the a value there is 1. So there's a really simple trick we can use. So I want you guys to factor both of these down, find the x-intercepts, sketch a graph of what the graph would look like, and then use that graph to estimate to find the intervals where the graph would be greater than 0. So go ahead and pause this video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So x squared minus 1, let's start with that. X squared minus 1, that's a difference of squares. So that factors down to be x plus 1 times x minus 1. The x squared minus x minus 6, that piece, we can factor that down. Now the trick that I was referencing is if the a value is 1, remember, all you have to do is find what two numbers multiply together to be -6 that add together to be that middle coefficient, the -1. And that would be 2 and -3. 2 times -3 is -6. 2 plus -3 would be -1. So when we factor that down, it's just x plus 2 times x minus 3, because we had 2 and -3. So then to find the x-intercepts, we're going to set each of those factors equal to 0. So the x-intercepts we get are going to be -1, +1, -2, and +3. So you just sketch a graph, throw those numbers down, those x-intercepts down. And now we want to identify where is it going to be greater than 0. Where is it going to be positive? So that would be above the x-axis. So that's going to happen on those intervals, or those parts of the graph that I highlighted in yellow. So now to identify those intervals, that first piece there, on the far left, would go from -infinity to -2. That middle hump, that's positive. That's going to go from -1 to 1. And that far right, that portion of the graph there, would go from 3 to infinity. So that is how we can identify the solutions for an inequality by graphing. So just because it says by graphing doesn't necessarily mean that you always want to depend on a graphing calculator. You need to know how to be able to sketch these by hand as well. All right, so let's summarize what we've done in this section. So again, what I would strongly recommend, if you haven't already been doing this, is as we go through each section, have like a separate sheet from your notes that has each kind of a summary for each section. So in that way, you don't always have to be going through your notes to access some of that key information. So the key information here is that if we have a function in the form of x minus a squared times x minus b cubed times x minus c, the values of a, b, and c would be your x-intercepts. So that's what the graph is showing us there. And so for this problem, since x minus a is squared, it's going to have a multiplicity of 2 at that x-intercept. For x minus b cubed, that's an odd, so that's going to have a multiplicity of 3, so that's odd, so it's going to go through that x-intercept. X minus c, that has a multiplicity of 1, so it's also going to go through that x-intercept. But I forgot to say this, that the x minus a squared, since that multiplicity is 2, it's even, it's going to reflect off or bounce off or have a turning point at the x-axis at that coordinate. So that summarizes in a nutshell everything that we've been doing in this section. So hopefully now all of that is starting to make sense as you finish this lesson.